Hey everyone, so welcome to our special week. I think this is number 2. So this week we're really working on catching up if you have fallen behind in computer science, or if you are caught up, you're working on what we call enrichment. So this is just extra stuff that's really going to help you kind of leap forward in computer science. So this is one concept that's not always introduced in a computer science class, but I think it is 100% necessary. So I think it's going to be a lot of fun to go through. And I'm going to try to give you some visuals to kind of learn this and kind of go along with the readings that I'm going to post in the OHS. So I'm going to be posting this long reading that goes really into detail about the binary chop. And you'll get a new page of that reading every single day. So it's a lot of reading. So I wanted to kind of give you some visuals to go along with it, so it kind of breaks up the monotony of just reading papers over and over. So this is called the binary chop. Now, as you can see on my desktop, this is an array. So now this is not any array that you would see in maybe Java or Python, but it's kind of pseudocode, and it looks like most arrays will look. So we have the name of the array right here. We have the equal symbol, and then we have brackets. So there's always some kind of brackets that separate arrays, and then inside the array we have this. We have these values, numbers 1 through 10, right? So basically, what the binary chop does is a very efficient way to find a value inside of an array. So anytime that you need to find a certain value inside of an array, no matter how large it is, the most efficient way to find that value is by using something called the binary chop. Now, we could randomly guess the numbers if we wanted to, but the problem is the least amount of chance or guesses that would take to guess is going to be 1, obviously. So we could get really lucky. We have a 10% chance if I were to guess 4, and maybe that is the number that we're looking for, but that's not very good odds. And actually the most amount of guesses is 10, which is not very efficient at all. So we don't want to be guessing randomly. So we do what's called a binary chop. And basically what a binary chop is it's going to be cutting down half of our options once we know that our option resides within a certain value. So for example, right now our minimum is 1 and our maximum is 10. Well, maybe we could guess 5. And then if we know what the computer can tell us is, okay, well, maybe it's higher or it's lower than 5. Well, let's say it's lower than 5. We can chop all from 5 all the way to 10. And we know that none of these are our value. So we've just effectively broken down our chances or our options from 1 to 10 to 1 to 4. So now our odds are 25% if we were to throw in a random guess. Now, we could do 4 random guesses, and we've already reduced our possible maximum guesses from 10 guesses down to 5 guesses. So this is a huge thing in programming. This is something that your computer does all the time. So all those millions of processes that your computer's CPU is doing every single second, this is what it's doing a lot of times. It's looking through these massive arrays of values, and it's just binary chopping them down until it finds the right value that it wants. So that's also how it's able to get through your massive hard drives very quickly. So I have another kind of visual for you. And as with most things in computer science, it can be told with playing cards. So I love using playing cards as an example. So I have my card here, and I'm not looking at my card. So I don't know exactly what this card is. But I'm going to place this in the deck, and we'll pretend like this deck is our hard drive. And I'm going to leave it up just a little bit so I don't lose it in this massive amount of cards. So this is our hard drive, and this is the file that I've stored somewhere on this hard drive, right? Well, I, as a computer, may know that as a reference that this file is somewhere on this half of the hard drive. So maybe I know that it's not on this whole half of the hard drive. So effectively, I will chop it down by getting rid of that half as part of my guess because I know it's not there, right? So then maybe the second part of the reference on that file is that I know it's not in this half either. So let's chop that down, and we're going to break that in half again. So as you can see, our chances are already significantly higher that if I were to guess, I'm going to find my card, okay? So, but maybe we have one more reference key. Maybe we have one more, and it's going to effectively chop off this half because we know it's not there. All right, so now we could just guess, but the cool thing about our computers is they actually binary chop until there's just one left. So even though it might be efficient to just go ahead and just grab all 6 of these files and try to find our own, it will slowly chop it in half until finally you're going to get down to either 2 or 3. In that case, it would chop 1, and then it's going to chop this left side again, and then we have my card at the end of the binary chop. So this will be the file that my computer was trying to find on that massive hard drive. And so it's a really cool way to break down these monstrous arrays. And so what I'm going to do is I'm going to post that article for you to read. Take a look at that article. It goes into really cool depth about how computers do this, and it'll even give you some examples of code from actual programming languages on how we do this. Now, if you're in my game design class, this is kind of a bonus for you. All right, you've already programmed a binary chop for our first Unity game that was called Number Wizard. So if you get a chance to take a look at the article, go ahead, and then tomorrow I'm going to send out another video that will go even deeper into the binary chop, and we'll start working on our project. All right, so thank you guys for watching. I will see you in class at 8:30 a.m. See you.